Hello friends, today in this video we are going to study about invertible function. First we know the definition of invertible function. Then we know how to check a function whether it is invertible or not. If a function is an invertible function, then how to find the inverse of that function we learn in this video. So friends, let's start. See, invertible function. F mapping from A to B and G mapping from B to A. Let f function mapping from A to B if there exists a function which is mapping from B to A, let it be G function. Okay? Such that GOF is equal to identity function on set A and FOG is equal to identity function on set B. Then f is called an invertible function and G is called the inverse of the function f. Okay, and we write G is equal to f inverse, or you may write directly GOF is equal to IA. You can write f inverse of f is equal to IA, and FOG is equal to IV, and you can write f of f inverse is equal to IV. Okay, so here the function f is mapping from, this is set A, this is set B, this is set A. Function f is mapping from A to B, where we get the unique element in set B is f of x, and G is mapping from B to A. This, then we get the function, the mapping from B to A, we get the element G of f of x. Okay, then the GOF is, you know, this GOF is equal to this, GOF of x is, you get the element G of f of x. Okay, and as this is mapping from A to A, the function is mapping from A to A, so we have IA, identity function from A to A, and which is equal to GOF. Okay, and if the function is mapping from B to A, that is, you know what, G, B to A. Okay, g of y, and f is mapping from a to b, a to b. Okay, that is f of g of y, this element. Okay, we get the image of y in set A, which is g of y, which is a unique element. Okay, and we get the image of this element in set B, that is f of g of y. And you know, the fog is mapping from B to B, fog of x, that is equal to f of g of y. Okay, and as this function fog is mapping from B to B, and you know that is identity function on set B, so this fog is equal to IV. Okay, if this GOF is equal to IA and fog is equal to IV, then function f is called invertible function and g is called inverse of f. Understood? And you remember this GOF, this can be written as g of f of x. Fog, f of g of y. Here y is there. Okay, this. Now come to a theorem, that is if function f is mapping from a to b, which is 1 1 onto function, prove that f is an invertible function. Here what given is the function f is a 1 1 and onto function. Then we have to prove f is an invertible function. So let's prove. Let y belongs to B set. F is mapping from A to B, which is 1 1 and onto. So let y belong to B and f be 1 1 function and onto function. But f is 1 1 and onto, so there must exist a unique element, that is x, in set A, such that f of x equal to y. As f function is mapping from A to B, as this function is a 1 1 and onto, so for each element of B there exists x in set A, such that f of x is equal to y. Understood? Now we define another function which is g, mapping from B to A, in such that g of y is equal to x. Okay, we define this. Now you see here, if we show GOF is equal to IA and FOG is equal to IV, if we show these two conditions for the function f and g, then we can say yes, function f is an invertible function and g is the inverse of f. So now we find this one, GOF of x, this, okay, g of f of x, we can write g of f of x, and you know g of here f of x is your y and g of y is x. Here we have defined already we have defined, and this can be written as IAX. So here we find GOF of x is equal to IA. First condition satisfied. Now we go for the second condition. Second condition is FOG of y. So FOG of y, you may write f of g of y, and you know this g of y is your x and f of x is y, and this can be written as IV of y, and that is equal to FOG is equal to IV, and IB is an identity function which is mapping from B to B. Okay, so this FOG is equal to IV. Now two conditions are satisfied, so we can write that f is an invertible function. F is an invertible function. Okay, and g is the inverse of f. So we can write g is equal to f inverse. Okay. Now theorem 2. If function f mapping from A to B is an invertible function. Here what given? Now function f is an invertible function. Now we have to prove that f is 1 1 onto function. Just reverse of the theorem 1. Okay. So here already given f is an invertible function. This is given. We have to prove the function is 1 1 and onto. This we have to prove, and this one given. So let's start. So f mapping from A to B be an invertible function. As the function is invertible, so there must exist a function, let it be g, which is mapping from B to A, such that the two conditions must be there, IA, GOF is equal to IA, and FOG is equal to IV. Okay, as this f function is an invertible, so we must have an inverse of that function f, let it be g, which is mapping from b to a, such that gov is equal to ia and fog is equal to iv. This is given up to this given, this is given. Now we have to show it is a 1 1 and onto function. You know that how to check 1 1, you know, if we take suppose f of x1 is equal to f of x2, there you call, if we show x1 is equal to x2 for all value of x belongs to a, okay, then we can say yes, function is a 1 1 function. So first you consider this f of x1 is equal to f of x2, okay, and we can write as these two values are equal, so we can write g of f of x1, g of f of x2, we can write. And as for the definition, you know, gov of x is equal to, you know, g of f of x. If this is, then we can write this, okay. So here you can write gov of x1, here gov of x2 we can write, and here already given that gov is your ia and fog is equal to iv. So here you can write iv. Gov, here ia, here also gov, so ia. So as input x1, so you get x1, here input is x2, so here you get x2, so they are equal. If f of x1 is equal to f of x2, then we can have x1 is equal to x2. So this function f is 1 1. Understood? Next. So now we show that this function f is onto. For that, what we have to do? You know already how to check onto. For each value of y, function is mapping from a to b. For each value of y belongs to b, there exists x in set A, such that f of x is equal to y. If we show this, then we can say yes, function f is onto. So here you come, g, let y belongs to b and g of y is belongs to a set, that is x equal to g of y, which there exists an element in set A, that is x equal to g of y is equal to a, such that f of x is equal to f of g of y, that is equal to fog of y, and fog you know already, I b of y is equal to y. So we get f of x equal to y. So if y belongs to B, there exists x in set A such that f of x equal to y. So the function f is onto. Here you can do like this also. G of y equal to x, and you can take both side f, then you get f of g of y is equal to f of x. Here you can write fog f of g of y is equal to f of x. Here f of this condition already given as it is an invertible function. So you can write here iv of y is equal to f of x. And you know the identity function that is mapping from B to B. It is defined as B. If we give the input y, we are getting y for all value of y belongs to B. So we can write here y is equal to f of x. So here what we have, now for each y belongs to B, there exists x in set A, that is x equal to g of y belongs to A, such that f of x equal to y. So the function f is 1, 1 and onto. Okay. So here you remember it, f is invertible if and only if f is 1, 1 onto. Okay, that means if f is 1, 1 and onto function, then obviously we can say f is invertible function. If f is an invertible function, then the function f must be 1, 1 and onto. Understood? Now we prove that an invertible function has a unique inverse. That means an invertible function has exactly one inverse function. Okay, so now let's prove. Function f mapping from A to B, which is 1, 1 onto. Here what given? Function is invertible function. Invertible function means it must be 1, 1 and onto function. So we consider a function that is f mapping from A to B, which is 1, 1 onto. Directly we can write. And therefore invertible, if possible, let it has two inverse. Here we have to prove it has only one inverse. Okay, but if possible, by the method of contradiction, okay, if possible, let it has two inverse. Let one be g function and another is h function. A function has let what? Two inverse function, that is one is g and another is h. Two inverse function. So as this function f is an invertible function, so it must satisfy two conditions. that is fog is equal to IV, okay, and GOF is equal to IA. These two conditions must satisfy. So here fog is equal to IV, FOH is equal to IV, as G and H are both inverse of what? Now F, so we can write F of G, that is fog is equal to IV, and FOH, that is equal to IV. Both we can write IV. As right sides are equal, IV, so we can write left sides are also equal. So here you take fog of Y is equal to FOH of Y, okay. So now you can write like this, F of G of Y, here F of H of Y, and you know that the function f is both 1 1 and onto. So as it is onto 1 1, as it is 1 1, so we can write f of x1 is equal to f of x2, which implies that x1 is equal to x2. We can write. So here you see f of g of y, here f of h of y. So we can write g of y is equal to h of y. We can write h, the function is 1 1. So here you write g of y is equal to h of y, okay. Here input is same y, so we can write the function are also equal. So g is equal to h. So the two function we have taken, two inverse we have taken, but they are equal, they are equal. So we can say an invertible function has a unique inverse, has exactly one inverse. Understood? That is, f has a unique inverse. Now we know how to find the inverse of a bijection. You know, the function which is both 1 1 and onto, that is called bijection function, bijective function, okay. So for a bijection, for a bijective function, we must have the inverse, okay. That means a bijective function is invertible, okay. So no need to check, okay. Directly we have to write, as f is a bijective function that is mapping from A to B. The first step, if function f is not given that it is a bijective function, then you must check whether function f is a bijective function or not. If function f is not a bijective function, then we cannot find the inverse of the function f. So first step in method 1 is, first you check the function f is a bijective function or not. If it is bijective, then you go to the second step, okay? And if it is not bijective, then you cannot find inverse. So no need to find inverse of that function, okay? So now come to, as it is bijective already given in step 1, f is a bijective function, proved. So we go to the second step, that is you write f of x equal to y, where y belongs to b and x belongs to a, okay? Now you solve this equation, okay, and you write this equation in term of y. Here you simplify it and you write this x in term of y. You write x in term of y. This is very important, okay? Now in fourth step, replace x by f inverse x in the relation obtained in the step 3 to obtain the inverse of f. Here we take an example for more clarity. Here you see f of x is equal to this function, that is 1 minus x by 1 plus x, where x does not equal to minus 1. Then find f inverse. This function is already a bijective function, okay? It is given f function is bijective already, no need to check now. Just we have to find the inverse of this function f. First step, okay, finished because it is a bijective function already given. Now come to second step. Second step is f of x equal to y. You write f of x equal to y. Then third step, solve this equation and write x in term of y. So you simplify here, you know f of x is your 1 minus x by 1 plus x is equal to y. Now you simplify, okay? You multiply 1 plus x with y, then you get 1 minus x is equal to y plus xy. Then 1 minus y is equal to x plus, you take this x to right side and y left side, okay? Then you get 1 minus y equal to x plus xy. Now you take x common, then x into 1 plus y. Then you can write x in term of y, that is 1 minus y by 1 plus y. Here multiplied, so if you take left side, then 1 minus y divided by 1 plus y. So you get x equal to 1 minus y by 1 plus y. Now you can write this in the place of x. In the place of x you can write f inverse y. Why? You know f of x equal to y, so x equal to f inverse y. So in the place of x you can write f inverse y. So here you write f inverse y is equal to 1 minus y by 1 plus y. Okay, and now you can change variable. Okay, instead of y you can write x also. So here f inverse x is equal to 1 minus x by 1 plus x, where x belongs to which set? B, because you know f inverse is mapping from B to A. So here x belongs to B set. Then this is the inverse of function f. Okay, this is a method 1. Now come to method 2. Here in method 2, first thing you must have to check whether the function is bijective or not. If it is bijective, then you proceed. If it is not bijective, then no need to find the inverse, because inverse does not exist for not bijective function. Okay, so here you see in the formula f of x, here you see replace f of x by x. You have to replace f of x by x. You write x in the place of f of x, first step, and then x by f inverse x, and you write in the place of x you write f inverse x, then you simplify it. Okay, simplify the relation obtained in the step 2 to get f inverse x. This is the second method. These are the steps. So here, as it is f is a bijective function, already bijective, so no need to check. Okay, here given. Now you find f inverse. So first step, you write this f of x equal to 1 minus x divided by 1 plus x. Now you replace f of x by x. So you can write in the place x, and x by f inverse x. In the place of x you write f inverse x, f inverse x. Now you simplify it. You multiply this with x, then you get x plus x into f inverse x is equal to 1 minus f inverse x. Now you take this to left side and this x to right side. Then what you get? X into f inverse x plus f inverse of x is equal to 1 minus x. Then you take common f inverse of x. Then you have x plus 1 is equal to 1 minus x. Okay, that is equal to f inverse x equal to 1 minus x by 1 plus x. This directly you get. Okay, in this way you can find what? Inverse of a function. Now here question given, f function is mapping from n to y, be a function defined by f of x is equal to 4x plus 3. This y is this for some x belongs to n, so that f is invertible. Then you find the inverse. Okay, so first you have to here prove what here you have what y belongs to small y belongs to this set capital Y, and y is equal to 4x plus 3. Okay, then you can write y minus 3 is equal to 4x. As you know, f of x equal to y we generally write, so in this place you write y. So here y minus 3 equal to 4x, then x equal to y minus 3 by 4. Okay, now you first define a function which is mapping from y to n. Let it be g function. Okay, f is mapping from n to y, and you define a function which is mapping from y to n. Okay, so define g mapping from y to n by this one, that is g of y equal to y minus 3 whole divided by 4. Okay, now we have to show, if we show GOF is equal to in, here set is n, and fog is equal to iy. Okay, then this function f is invertible. Okay, this is method 1. Okay, to check invertible. And method 2, you know, you just show the function is 1 1 and onto, both 1 1 and onto, then we can say function is invertible. So this here we do by this method. Okay, just we satisfy these two conditions, then we can say function f is invertible. Okay, by this also you can check whether the function is invertible or not. First we do this. Okay, so see here g of GOF of x is equal to g of f of x. Here you see f of x is equal to 4x plus 3. So you write here 4x plus 3 in the place of f of x. Then as you know, we have defined g of y is equal to 4 y minus 3 by 4. So g of here y is what? 4x plus 3. Here input is y, here input is 4x plus 3. So you can write 4x plus 3 minus 3 by 4. So 3 cancel. So 4x by 4, 4 cancel, then you get x. X means what? In of x. So you got GOF is equal to in. Okay, Now come to fog. Fog. Here I have written x, but here it will be y. Okay, fog of y. So fog of y, you can write f of g of y, and you know f g of y is what? Y minus 3y 4, and f of x is how much? F of x is equal to f of x equal to 4x plus 3. Here input is x. Okay, so here x. If input is this y minus 3 by 4, then you can write 4 y minus 3 by 4 plus 3. So that is equal to 4 cancel, then you get y minus 3 plus 3. Then 3 cancel, then you get y. So that is equal to what? I y, that is identity function on set y of y is equal to y. So you can write fog of y is equal to I y of y, that is equal to fog is equal to I capital Y. Okay, so now two conditions satisfied. Okay, here you remember, here y. Okay, y, by mistake I have written x, here y. Okay, so two conditions satisfied, that is gov is equal to in, fog is equal to I y. So f is invertible function. So g is inverse of f. G is inverse of f. And you know how to find inverse of f? You know already. First step is f of x is equal to y, you can write. Then you write 4x plus 3 equal to y. Then you write in term of x, you write x in term of y, that is 4x is equal to y minus 3. Then x equal to y minus 3 by 4, and in the place of x you can write f inverse y is equal to y minus 3 by 4, and you can change the variable also, that is f inverse x is equal to x minus 3 by 4. So this is your inverse. Okay, inverse of f. Understood? Now we can show this function is invertible by showing f is 1 1 and on 2. Okay, how? You see, first we show 1 1. Okay, first you write 1 1, f of x1 is equal to f of x2. If we show this equal to x1 is equal to x2, then yes, the function is 1 1. Yes, so here f of x1, here you can write 4 x1 plus 3, x2 4 x2 plus 3. Now you take this left side, here 3 cancel, then we get 4x1 equal to 4x2, then this 4 cancel, then you get x1 is equal to x2. Yes, this f is 1 1. Okay, now we show f is onto is this. Let y belong to capital y is equal to 4x plus 3, then you write like this, and you write x in term of what? Y, that is equal to x equal to y minus 3 by 4. Okay, first you find this one. Okay, now for each y belongs to capital Y, there exists x that is equal to y minus 3 by 4, which is belonging to the set N, such that f of x that is equal to f of y minus 3 by 4, and you know that function f of x that is equal to 4x plus 3, so there you put, then you get 4 y minus 3 by 4 plus 3. Okay, then 4 cancel, then you get 4 minus 3 plus 3, then 3 cancel, then you get y, that is equal to f of x equal to y. So this function f is onto, so f is 1 1 onto function. Okay, so we can say f is invertible. Understood? Okay, first you show in method 1, you show GOF is equal to in, FOC is equal to iy, to check whether the function is invertible or not. Or you may do f is 1 1 onto. If you show a function f is 1 1 and onto, then we can say f is invertible. Understood? To check the function f is invertible or not, you may show this or by this way. Okay, thank you.